On the previous screencast, I left off at looking at the breakdown of municipal solid waste by source and mentioned that 30% is for the sources, containers, and packaging. So that's really a big area that we might be able to target. If I had mentioned the example of Amazon, if you have bought cereal and you open the box, it's a nice big box, and then you open it up and find it's only 3/4 filled. That is an example where, for advertising purposes, the manufacturer wants you to believe that you're getting a bigger box of cereal than you really are. Same applies to over-the-counter medicine and many, many other things you might think of. Another big area that could be targeted is food and yard waste, which is 25% roughly of all. It's the source of 25% of all of our waste. And that too is great for targeting because it can be composted. Next, we'll turn the attention to EWaste. The E stands for electronic waste. And that's the waste that is in televisions, computers, cell phones, iPods, gaming devices, etc. And all of these devices contain toxic metals. The leading toxic metals are lead, which you've heard of before, mercury, which you've heard of before, and one that you might not have heard of before, which is cadmium. The EPA lists cadmium as a probable human carcinogen. Not possible, probable. And they also state that it causes lung irritation and probably cancer. So if it's contained within your cell phone or computer, then it's not thought to be endangering you. The problem is, how do we dispose of these devices when we're done with them? Typically, the devices are often sent overseas where they are dismantled, and people will be looking for the metals so that those can be collected, and they can receive money for recycling those, if you will. The problem is that the way these materials are extracted from the electronics are with acids and fire. So that can often lead to unsafe working conditions. A second issue is that it takes tiny fingers to get in there by the way these materials have been designed. And therefore, there are times when children are doing the dismantling, or potentially women, if not children, because of the smaller hands to get at things. The number of electronic devices is also growing. It's growing within the United States, and it's growing overseas. So that compounds the problem. An additional issue with e-waste is air pollution and water pollution, because you have all of these materials that are dismantled from the electronic device, and the ones that aren't being sold for money then have to go somewhere. So there might be plastics and other metals and just other materials that are then basically put in a dump outside of the exact surroundings of the community. And as it rains, materials that are toxic in that dump can run through the computers, the discards from the computers, and get into the water supply, which is often an aquifer right below, or could be a river right next to the place where these materials are being dismantled. There are some materials that are e-waste, that is dismantled in the United States, but it's very hard to find out where your computer or printer or whatever is going for recycling. Okay, so we are concerned about e-waste because out of the entire world, the United States produces about half of all e-waste. And not much of it is being properly recycled. It said in your textbook that only less than 20% of discarded computers and TVs in the United States are recycled. I did check out that number, and we have increased quite a bit. It's up currently to about 40% of discarded computers and TVs being recycled. That seems to be largely in part to sellers like Staples and Best Buy offering some type of buyback system or a discount when you return the materials to them to get something new. Some places even accept it even if you're not buying something new. They'll still take it and recycle it. But unfortunately, globally, the number is still 20%. So as we improve our recycling rates in the United States, globally, it's still not a good picture. Let's see. We've already discussed the export to other countries, so I'll move on. Okay, now we're going to look at a very important factor, reduce, reuse, and recycle, as well as composting. And this is something that we have somewhat in our control, so that's why one of the reasons why it's an exciting area to look at. So the idea is the 3 R's are listed here in order of best approach. The best approach would be to reduce the amount of waste produced. And once we reduce the amount of waste produced, then the next item we would want to turn our attention to is reusing something as often as possible, and thirdly, recycling. So you might wonder why recycling is all the way down there at number 3. It actually takes energy and water to recycle a product, and often, or most typically, it isn't recycled into the same product. So when you recycle a water bottle, it doesn't become a new water bottle. And it takes a lot of energy and water to recycle the plastics in it. So that's good. All of these are great, but it's not number 1 for recycling. Right up here with reduced, maybe I should move the word right next to it, is composting. Because composting reduces the amount of waste that goes to a landfill. And when we saw before how things like lawn clippings and other yard material and things like some paper can be composted, then you can see that that would reduce the amount of trash left over to go to the landfill. So that's also a good thing. So let's look more carefully at the concept of reduction. Waste prevention and minimization really needs to mainly be done at the point of manufacturing and distribution. So if someone is designing, let's say, electronic products, they could do so with less toxin, make the material easier to dismantle and easier to recycle, then that would be waste minimization. On a home note, one thing that you could do to reduce the amount of waste that we produce is to either not print papers at all, or at least if you are in need of printing a paper, use two-sided printing. That cuts down the amount of paper use in half right there. So source reduction needs to take place through better design and manufacturing, less packaging. Definitely could do with less packaging. And material substitution means using something, for example, they are now coming out with plastics that can be recycled more readily, and even possibly biodegradable plastics. And that would be an example of material substitution. Okay, reuse is the second R, and to reuse something means to use it more than once. And when we participate in swap shops or buy things on Craigslist or eBay, for example, then we are encouraging the reuse of materials, and that's good. So consider a pair of jeans. This always got to me as my kids were growing up and they were outgrowing their jeans very quickly. Why go out and buy, a $30 or more pair of jeans when you can go to Goodwill and get perfectly decent jeans for $1? And not only are you saving yourself money, which you can use for other things, you're saving all of the energy, irrigation, pesticide, and transport that goes into making or growing cotton that's then used for making cotton jeans. So that would be another example of reuse that benefits the planet and you. And this last example I have here is a pub in England where they had what they called tuba toilets. I'm told these really aren't tubas. I don't know what they are, but they're brass instruments that are then that were converted into use as toilets. Nowadays brass is very expensive, and I don't think anybody would be turning them into toilets, but brass is an example of something that can be recycled, but in this particular case it's being reused. Okay, now we're going to look at the third, recycle, the third R. So materials are collected and they're converted into other raw materials that are used to produce new objects. And typically, recycling is done for paper, glass, aluminum, steel, and plastic. And there are two types. The first is closed loop, and the second is open loop. So in a closed loop, we have the example that petroleum raw materials are turned into carpet fibers. And those carpet fibers are made into a carpet. And that carpet can be collected and recycled. And when it is, it typically makes more carpet fibers, which are turned into a carpet. So it's a closed loop because it's going in one circle. One product is recycled into the same product. But again, it takes energy and water. In an open loop, you have a different product produced. So you have petroleum products that are used to make a plastic water bottle. The consumer uses it. It's recycled. It's taken to a recycling plant where it's not turned into another water bottle, but it can be turned into fibers. And those fibers can then be used to make the insulating lining to a jacket, for example. So it's turned into something else. But that's better than being in a landfill. So for the last slide on the 3 R's, we're going to take a look at the total municipal solid waste that's recycled and the percentage recycled. And so you can see here the orange line that approximately a little more than 30% of municipal solid waste is recycled. And totally we can be up here to the high number of 45%. And again, there's a hint that there might be a positive, actually that would be a negative trend down with the amount recycled. But in fact, both of these numbers have simply plateaued through to today, so nothing has really changed here. And I think I'll continue on a different video, a different screencast to move on with composting.